So we're in the last part of chapter 1 when we're exploring data. Right now we're talking about the numerical summaries that we do with quantitative data. Remember, whenever we're attacking a problem, we plan how we're going to collect our data, and then we're going to graph that data, choosing the correct graph that's going to help us solve our problem, and then we're going to do some numerical summaries. So we're going to start talking about some of the numerical summaries we can do with quantitative data. Here are your objectives. Measures of center, we're going to calculate our mean and median. We're going to look at measures of how spread out things are. We talked about describing a graph, including talking about how spread out it is. And so we have some numerical things we can talk about: the range of the data, the interquartile range, or the IQR, we're going to talk about in a little bit. Standard deviation. When we're dealing with, please excuse me, measures of center, there are times that the median is a better measure to use because of outliers. We'll talk about that. We're going to have a rule that will allow us to identify if it's something that looks outside of the pattern of the rest of the data actually is an outlier. We're going to use 5-number summaries to create box plots, and then we're going to compare box plots together. We're going to compare histograms, and then we're going to go ahead and put it all together and make some summaries. This is the statistical way of talking about the mean. And you know that the mean is just add them all up and divide by the number of numbers. Remember, n is always going to stand for the number of trials or the number of data points. Excuse me, please. And x bar stands for the mean of a set of observations. We have one other kind of mean that we're going to talk about later, which talks about a population mean. It's a bigger thing. But right now, we all know how to calculate the mean. You add them all up, the first set of data, the second set of data, all the way down to the last set of data, and then you're going to divide it by the number of numbers. So the median, on the other hand, is just the center number when the distribution is put in order from smallest to largest. And if the number of observations is odd, that median's right there in the middle. Like here's our set of wacky 3 data points. Here's our median. If it's even, then you're going to go ahead and look at the average between the 2 middle numbers. So in this case, the median would be 2.5. Later, we're going to talk about what we do with the bottom half and the top half of the data when we do a 5-number summary. When the median is the average of the 2 middle numbers, this becomes the bottom half and this becomes the top half. When it's an odd number, the median doesn't count in the bottom half or the top half. Oh. Huh. Here is a representation of these data points being added up together and divided by 20 of them, because there are 20 total workers. And then here is a stem and leaf plot that's been created for it. And since the stem and leaf plot is already in number order from smallest to largest, then you can very easily use it to count into the middle to find the median. So make sure you count accurately though. Here's 5, here's 10, 10, 10, 10. So you're going to count until you get to the middle. And here is the bottom middle. And then here is the top middle. And then when you go ahead and take that 20 and the 25 and divide by 2. Notice, reminder, we've got a key right here that tells you the line 5 represents a 45-minute travel time to work. So remember, you know how to read and write the key for a stem and leaf plot. This particular slide just talks about the interquartile range, but I'm actually going to use it to talk about the 5-number summary. So a 5-number summary takes your middle number, your median, and it cuts the, so let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as our data points. Our median is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Our median be right here at 5.5. Now we're going to go ahead and find our first quartile. And we do that by cutting that lower 50% in half again. So here we have these 5 numbers, 1, 2, 3, 4, 5. This 3 is our Q1. And then we have our median, and then we're going to do the same thing for the third quartile. We're going to go and find the middle number of this one, which is the 8, and that's considered our Q3. The interquartile range is the difference between our Q3 and our Q1. So in this case, the interquartile range, or the IQR, and you're going to hear that a lot, is 8 minus 3, or 5. Okay? But this is how you calculate your 5-number summary, which I'm going to talk about again on the next page. But what you do, the 5 numbers, by the way, come from the minimum. Whoops, I lost my pen there. Comes from the minimum. Weird. Minimum, the maximum. So the minimum, your Q1, your median, your Q3, and your maximum, those are your 5 numbers. And with that, we can do a lot of work, including creating box. So that interquartile range, this is another example of it. They have taken the data, they put it in order. Then they find the median by going into the center of the data. In this case, once again, the median is 22.5. And then they look for the middle of the bottom half of the data, which is, in this case, is 15 and 15, so the average is 15. And the middle of the top half of the data, the average of that is 42.5. Interquartile range would be the difference of these two. 42.5 minus 15, which would give you 27.5 minutes. We often look at how spread out data is by looking at the IQR, or the interquartile range, looking at the difference between Q3 and Q1 instead of just the whole range, because sometimes there's an outlier that can really confuse the whole thing, and so instead you're looking at the middle 50% of the data. This is 50% of the data there. And so that gives you a piece of information that's resistant to those outliers that might confuse the information. Speaking of outliers, we can visually see if something might seem an outlier, but what we actually are going to use every time is the rule for outliers. And so we start by taking that IQR. In this case, we found out that the interquartile range, the interquartile range was 27.5 minutes. So we're going to find what 1.5 of that interquartile range is. So we're going to do 1.5 of 27.5. And so then we're going to go ahead and realize that that number is 41.25. And since here's our median, right? And here's our outlier, here's our Q3, here's our maximum, here's our Q1, here's our minimum. If we are trying to decide if this number is an outlier, we're going to take the Q3 and add it to 41.25 to see if this number is outside of the pattern of data. So we take that 41.5 and we're going to add it to the Q3 in this case, which is 42.5. So we are going to say that anything that is above 83.75 is considered an outlier. And that's true about this one. Okay? So it is mathematically, statistically an outlier. It looks like it might be, but it's also statistically, that's what we use. We use 1.5 times the IQR. And if we were trying to decide if that if that 5 is an outlier, we would do the exact same thing, but in the reverse. We'd find the fact that 1.5, the IQR, is 41.25. Then we're going to take the Q1 and subtract the 41.25 and see what happens. And so since the Q1 is 15, 15 minus 41.25 is a negative number. So this is not an outlier, but this one is. So when we're talking about center and we're talking about spread, the 5-number summary gives you a lot of information to work with. I've given us a really simple, tiny data set right here. The median is 5, the minimum is 1, the maximum is 5, and the Q1 is directly in the middle, and the Q3 is directly in the middle of the median and the maximum. So here is my 5-number summary. And I'm going to use that to create a graph called a box plot. It's pretty straightforward. Once you've done this, all you're going to do is, so we're going to quickly learn how to make a box plot. So first we need to find our 5-number summary. So we're going to go ahead and we're going to look at the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. That means 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Right here in the middle of the 7 and the 8 is 7.5. That is my median. And I'm going to go ahead and make an x-axis here. So we're going to go from 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So actually this needs to go, I need to erase that since I put that there. 7.5, here is where my median goes. And then I'm going to go ahead and look at my upper, and we're going to go and find the Q3, which is at 10, and our Q1, which is at 2. Here is my box, and this is my interquartile range, right? And then we go ahead and go out to 12. We make a whisker out to the, excuse me, out to the maximum, and then we make another whisker down to the minimum. These are called quartiles, by the way, because they are cutting the data roughly into fourths. So each of these quartiles has roughly 25% of the data. One of the reasons we look at the inner quartile range is that gives us 50% of the data. And so that is a good concentration of the data, and it allows us to make some interpretations. So we're obviously going to practice this in class, but what you're going to do, I mean, you could stop this and look at this and not listen to me first and do it yourself. That's not a bad idea. So this particular set of data, our New York time travel, our median is right here at 22.5, and our Q1 is at 15, and our Q3 is at 42.5. So here is our box, and that's our IQR from Q1 to Q3 would be 42.5 minus 15. The IQR is not the box, it's the actual number. It's the distance between the Q3 and Q1. But you can look at visually that those two boxes together of the Q1 to the Q3. Then we have a strange situation where we have to go ahead and put our top whisker not to the absolute maximum. This one's an outlier, so we're going to go ahead and write that one with with an asterisk indicating that it's part of the data, but it's an outlier. And then we're going to go back to our minimum, which is at 5. So this is our box plot, which is drawn from a 5-number summary. Recall 25%, 25%, 25%, 25%. The middle set of the data in the box is 50% of the data.